And welcome back. It is the 10th of August. High five a day. I'm going to go straight to the first question. First question says the number of visitors. It's a standard form question, is it? So the number of visitors that a museum had last year was this number here. This year the museum had this many visitors. So obviously a higher number because it's 10 to the 6. Calculate the percentage increase. So this is clever. So it wants me to do 1.3 times 10 to the 6 divided by 9.2 times 10 to the 5. So this really is just a test that you know how to put these numbers in your calculator. So I'm going to do this in my calculator. So 1.3e on my calculator 6 divided by 9.2 e5. And that tells me 65 over 46, which is 1.4130. I'll write that down. So 1.4130. That is a multiplier. So that implies a 41.3% increase. Question done. Next question. Calculate the area of the right angle triangle. Now, in order to calculate the area of a triangle, I'm going to need the height and I'm going to need the base. Or I could use the sine rule and therefore just work out this side here. And that's what I'm going to do. So I'm going to note that I've got the opposite, the hypotenuse and the adjacent. So therefore cos of 58 is equal to the side that I don't know. I'm going to call this A. Which is going to be equal to A over 9.4, which means that A is equal to 9.4 cos 58. Then what I want to do, I want to calculate the area of the right angle triangle. Now using half ABC sine C, so using half AB sine C, which as I've said in several videos, you may not see this until the end of your course, so you may not have seen this yet, but you will come across this. So that's going to be a half times the sides, which is 9.4 times 9.4 cos 58 times sine of the angle in between, which is sine of 58. Calculator out, and that gives me 19.854. And I'm going to say that's 19. Let's do 4 sig fig. So 19.85 centimeters. Yep, centimeters. Centimeters squared to 4 sig fig. Question done. Next question. And no, not final question today. Water is poured into a swimming pool for 13 minutes. The graph shows the depth of the water in the swimming pool. What is the rate of change of the depth of water? Now, this is, if you do A-level maths, you can do a lot more about this whole rate of change and how things change. For the sake of this one, what we're going to do is we're going to recognize that's centimeters and that is minutes. So what I can see here is if for each minute, I go up, well, it's a bit hard to see, but it looks like a 1. So let's do 2 minutes. So for 2 minutes, I go up 2 centimeters. So in other words, it's going to be 2 centimeters per 2 minutes, which is also known as 1 centimeter per minute. Give your answer in centimeters per minute. Done that, question done. Another swimming pool contains water that is 24 centimeters deep. I think I know where this is going. So I'm going to start here at 24. It is emptied at a rate of 3 centimeters per minute. Show this on the graph. So again, it's saying, can you plot using this gradient? So in 1 minute, I've gone down by 3 centimeters. So I've gone down to 21. Then the next minute, I've gone from 21 to 18. You can probably see where this is going. Down by 6, across by 2, which means I'm going to empty the graph. Let me draw this in first. Obviously in your exam, get a ruler out, do it better than I've done it, which means I'm going to get a graph something like that that crosses at 8. Show this on a graph, question done. Next question and final question today. Final question is a similar shapes question. And I've got shapes, it's 3 shapes. I've got shapes A, B and C. Oh, this is quite a difficult question. And then it tells me A to C, tells me B to C, and then it wants the volume. Right, okay. So the way I'm going to approach this is I'm going to say that I want the ratio of A to B to C for the length scale factors. I'll find the length scale factors and then I can find the volume scale factors and then I'm fine. Okay, good. Know what I'm doing now. So the first bit's quite easy because the height of shape A is 8 and the height of shape C is 4, which means the length scale factor of A to C is 2 to 1 because A is 2 times bigger than 1. And it says the ratio of the surface areas of B to C. So the area scale factor from B to C is to multiply by 9 over 25, which means the ratio is going to be, well, B to C, remember this is area scale factors, is 25 to 9. I've basically just written the same thing again, which means the length scale factor is the square root of that, which is 5 to 3. So therefore I can write 5 to 3 here. The problem is I need this to be one ratio. So I'm going to multiply this one by 3. Yeah, 3. So multiply this one by 3, which is going to be 6 to 3. And I'm going to multiply this one by 1, which is going to give me 5 to 3. I finally got here. You can almost hear my brain working through this question. So therefore, I've got the length scale factors in terms of one ratio, which is going to be this ratio here. Now, if then those are the length scale factors, the volume scale factors are the cube of this, which is going to be 216 to 125 to 27. What does the question want? Question says, work out the ratio of the volume of the shape A to the shape B. There we go. So the volume of A to the volume of B is going to be 216 to 125. Wow, that last question was quite difficult. Quite enjoyed doing it, but you almost heard me work it out as I went. Either way, let me know how they went for you. Hopefully you got them all today. That last question again, difficult question. So well done if you got there. Do as ever, like, subscribe, and I'll see you for tomorrow. Thanks all.